Okay, so what we're going to be doing here is we're going to be trying to find the distance between 2 points that exist in the plane. So we create a segment, and of course right here I've got my segment AB. I've got the length here, it's 3.74, but let's just think about how in the real world, if there were 2 different points and we wanted to know the exact distance between those 2 points, how would we do that in the real world? Well, it turns out that in the real world we have a system whereby we can measure latitude and longitude, and then that gives us coordinates, right? So that's basically what we're doing in geometry, is we practice using coordinates to find length. So how does that work? Well, to get this, you kind of got to understand that there is going to exist a third point in the plane for any other 2 points in the plane, such that we can, divine the distance or figure out the distance here. And let's see how we'd find that point, okay? What we're going to do is we're going to create a line that's parallel to the x-axis that goes through this point A, and then create a line that's parallel to the y-axis that goes to this point B. And then where those 2 parallel lines meet, which they meet in a perpendicular fashion, the intersection point right there is point C. So now let's look at what we have. If we take off that segment there and we were to just draw, the segment here, if we wanted to know how long AB was, well, we could think about how far we've traveled from the x location of point A to the x location of point B, and that's what this segment represents. So the distance of this segment is how far along the x-axis you would have to travel to get from wherever A is registered on the x-axis to wherever B is registered on the x-axis. So we see that, and if I move B around, that leg is always just the measurement between A and B along the x-axis, okay, no matter where I put B, or for that matter wherever I put A. And then we can create another segment over here which tells us the difference between A and B, where they register on the y-axis. So if I move A around, it's just that segment there always tells us the difference between A and B wherever they are on the plane. Okay, you can see that segment there. So essentially what we have, if you look at that, we have 3 segments, and we're going to use these 2 segments to find the length of that segment. Now, maybe just from looking at this you can figure out how that's done. Hopefully you can recognize something. The important thing is to recognize that these axes are set at right angles to each other, right? So that the y-axis is always at a right angle to the x-axis, and since these lines that we created are parallel, it turns out that what we formed is always going to be a right triangle. So another way to say that is, for any points A and B, there exists a point C such that we can form a right triangle where AB is the hypotenuse of the right triangle. Now let's think about the right triangle here. What's the value of that here? Well, remember, this length here is a leg of the right triangle, and this length here is a leg of the right triangle. This length here is the hypotenuse of the right triangle. So what that means is we can use Pythagorean Theorem. So watch how I do this here. We know that the Pythagorean Theorem tells us that the leg squared plus the leg squared is equal to the hypotenuse squared, right? So if we want to, we can write this as L squared, right, plus L, squared equals H squared. Now, if you haven't seen this before, but that little arrow tells us that we are writing the next part in the superscript. So that's L squared plus L squared equals H squared, which just means leg squared plus leg squared equals a hypotenuse squared. So now let's just put that information there. We know that if we want to find the length here, if we can get this length here and this length here, this leg and this leg, then we can figure out what the hypotenuse is. And in fact, what we would say is we could take, to find out the hypotenuse, we take the square root of the hypotenuse, and it's going to be equal to the square root of L squared plus L squared. So let's write that in there. So we go the square root of L squared plus L squared is equal to the hypotenuse. So basically, this is our distance formula to get us, you know, the length here. We're going to take the square root of this leg and the square root of that leg, you know, whatever that leg might be. Now, how do we find the length of this leg? Well, let's go over here and look. This one is called segment B1, and we can see its measure right now happens to be 3.16. Now, how would we find that? Well, it's the distance between A and C on the x-axis. So as we travel from point X, actually, you know, point X to point B, the distance between A and B, so we have 4.5 minus 1.34, and it turns out that that difference is 3.16. So that's our length there. And if I change this, then we can say 4.5 minus 2.74, and that's equal to 1.76. So that's how we find this leg here. Okay? Then we're going to find this leg here the same way, only we're subtracting the y's. So in this case, it says that segment A1 measures 2.02. So that's the difference between the y value of B and the y value of A. So the y value of B is 3.9, y value of A is 1.88, and that is approximately, or actually 2.02. That is the length there between 3.9 and 1.88. It is 2.02. So now we can rewrite this. Instead of saying L squared plus L squared, what we can actually do is we can say that the first leg, so we're still gonna say it's the square root of, but in the first leg is gonna be x, the x coordinates. So let's say x of, say, the second point minus x of the first point squared. Oops, we're going to put that in parentheses. x2 minus x1, close parentheses, and square that. So this is the length of that first leg, plus y2 minus y1, and we'll square that. And there's the length of the second leg. And if we put that all together, it's equal to the hypotenuse. Or we could say, again, square root of x2 minus x1 squared plus y2 minus y1, and squared is equal to the distance. Distance. There we go. So this is really our distance formula right here. The distance is equal to, we find the difference. And remember now, we could take away that triangle, we can take away point C, but all we're really looking at is that there exists some leg here, right? The difference between A and B on the x-axis, right? And some length here, the distance between A and B on the y-axis. And if we think of that as the right triangle, we use Pythagorean Theorem and just solve for this length. And that's how the distance formula is done. Okay? I will go ahead and have you continue in your journey.